So good morning everyone and welcome to this lecture. This is lecture number 2 and we are dealing with center of mass. Do we remember what is center of mass, everyone? We had discussed about the concept of center of mass in the previous class. Do we remember what is center of mass? Anyone? Do we remember what was center of mass? No one remembers it? What was center of mass? Yes? Anyone remembers it? What was center of mass?
Sir,
What? What was center of mass, beta?
center of mass of a body or a system is a point whose the motion of the describe the translation.
Whose motion describes the translation motion. Anything else? Anything else?
Imaginary point.
Okay, it is an imaginary point and whose motion describes the motion of the entire body as a whole, the translation motion. Anything else? Anything else that you remember about center of mass? No one remembers anything? We can assume that the entire mass of the body is kept at the center of mass. All forces acting on the body, we can suppose that they are acting on the center of mass. Do we remember this? If you remember this, then please tell me, don't raise hands. There's no point of raising hands when you don't tell me. Please, when I ask something, tell me. Okay, I think we were doing this question um, in the last class. Anyone was able to do this?
Sir, answer.
Got the answer for this one? What is the answer for this one? Anyone got it?
See, sir, answer.
What is the answer?
See,
C. 0.63 Armstrong unit from the carbon atom. So you can assume that this carbon atom is placed at the origin. How do you find the center of mass of the system? The only way you can find out the center of mass, you only have to find out the x coordinate of the center of mass. Yes or no? So if I have to find out the x coordinate of center of mass, I will do m1x1 plus m2x2 divided by m1 plus m2. This carbon atom is kept at the origin, so m1x1 becomes 0. So basically it becomes m2x2. M2 is oxygen, mass is 16, multiplied by 1.1 divided by total mass is 16 plus 12, and that is your answer. Whatever you get, what are you going to get from here? I think you are going to get a 0.63 Armstrong unit from the carbon atom, and that is your answer. Everyone understands this?
yes, sir.
Okay. Let me give you the next question. This is the next question. Question number 1 for today. No, they're asking you the velocity. We have not done the velocity just now. Let me give you this one. Yes. Find out the answer for this one. The coordinates of the position of particles, three particles, mass is 7, 4, and 10 grams are given. You have to find the coordinates of the center of mass. I'll give you 2 minutes to do this. So this is the question. Four masses are placed at the corners of a square. You have to find out the distance of the center of mass from the point A. I'll give you 2 minutes. I hope you can do this question. Okay, what I'll do is I'll give you a hint. I don't know whether you have drawn the diagram or not, so I will give you a hint. Of the diagram. So here is the hint. The diagram is here. Remember, the diagonal of the square is given as 80 centimeters. So this is the diagram. I've drawn the diagram, and now I will hope that you are able to solve the question and give me the answer. I'll give you 2 more minutes. I've given you the diagram, and I hope to get an answer. So how are we supposed to solve this? It is given that the diagonal of this square was 80 centimeter. When I say the diagonal, that means this one. This is 80 centimeter. Once you understand that this is 80 centimeter, you can find out the length of the side. The length of the side will be coming as 40 root 2. All of us understand this? From the square ka diagonal, we can find out the square ka edge. Okay. Now, once you understand this, everything becomes simple. Instead of writing 40 root 2 always as the length of the side, we have the diagram, it is written as A. So coordinates of point B becomes A comma 0. Coordinates of point C becomes A comma A. And coordinates of point D becomes 0 comma A. We understand this, yes or no? Then we just have to find out the x position of the center of mass. And how do I find the x position of center of mass? It is summation of mi xi divided by summation of mi. I just put the values and get the answer. Now, for the first mass, it is placed at the origin, so I don't have to write it because it is at the origin, so m into x would be equal to 0. We understand this, yes or no? We just have to start from the second mass, which is body B. So I start with body B. Body B, the mass is 2 kg and the x coordinate is A. So 2 into A plus second body is C. X coordinate is A. Mass is 4. 4A plus the third body is D. Again, the x coordinate is 0, so I don't have to write it. Divided by the total mass of the system, 2 plus 8 plus 2 10 plus 4 14 plus 2, 16. So what do I get from here? What do I get? What do I get? 6a divided by 16, 3a by I think 8. And a is nothing but 40 root 2. So I get 15 root 2. Yes or no? No or yes? Then we find on similar lines the y position of center of mass. It is nothing but summation of mi yi divided by summation of mi. The y position of center of mass. The first body is at the origin, so don't have to worry about it. I will start from body B. Body B, also the y coordinate is 0, so don't need to worry. Body C, the mass is 4 kg, the x coordinate, the y coordinate is also A. For body D, y coordinate is A and the mass is 2 divided by 8 plus 2 plus 4 plus 2. Again, I get the same answer 3a by 8. So I get it as 15 root 2. X and y coordinates are 15 root 2. I have to find out the distance of the center of mass. So the distance of center of mass will be under root of x square plus y square. That is what you had to do. So 15 root 2 square plus 15 root 2 square. And I think the answer that you will get is 30. And that is the answer that we are looking at. I'll give you 2 minutes to note this question down. Everyone has understood this? Note it down. Then here comes your next question, and I hope that you can solve it quickly. Question number 3. You have to tell me the position of the center of mass of this system. 4 particles are there, A, B, C, and D, and they are placed in this way. Calculate the center of mass and let me know fast the x and the y coordinate fast. So, how are we supposed to do this? Again, the concept remains same. X position of center of mass is summation of mi xi divided by summation of mi. Oops, just a minute. So mixi divided by summation of mi, the first body, body D is on the origin, so you don't have to worry about it. You just put the values of the other bodies. M3, body C is having a mass of 3. You just have to remember which body has got which mass. 3 into 1 plus body B has got a mass of 2 kg, so 2 into 1 divided by 1 plus 2 plus 3 plus 4. I think you will get 5 by 10. 5 by 10 is nothing but equal to 1 by 2. To get the y position of the center of mass, you have to do summation of mi divided by summation of mi. You can put those values and you will get the answer as 3 by 10. Everyone getting the same answer, yes or no? Okay. I'll give you one more question. Now, remember, the more the number of question that you do, the better you are in solving. It's all about practice. So this is the question. You can imagine that the origin is at this point. Which point? This is your origin point O. From this point, you have to tell me what is the position of the center of mass. This is question number 4 on center of mass, and I'll give you 2 minutes to solve it. So take this question as a homework, leave some space, and get the answer. I will just give you the answer for this question.
Sir, answer is 5 by 3, sir.
The x coordinate is 1.3 centimeter. That is what the answer is given, and the y coordinate is 1.5 centimeters. So that is what the answer is given with me. Just check it out whether you get the same answer or not. Anyone getting the same answer? Okay, great. Then you can be proud of yourselves that you have done the question correctly. Now, this one last question that will finish, that will be the last question for this class. Consider a two particle system with particles having mass m1 and m2. The first particle is pushed towards the center of mass through a distance d. By what distance should the second particle be moved, and obviously in which direction, so that the center of mass remains at the same position? So, a very important question because we will be requiring conditions of this in solving some questions that are coming up. So, I'll give you this question, and I hope that you understand this question and will be able to solve it. You will get 2 minutes to solve this one out. Anyone able to do it? Well, as a hint, just to help you in solving this question, I will show you the diagram, and with the help of this diagram, I think, remember, diagram was not a part of the question. So I'm showing you this diagram. I hope with this diagram you would be able to solve this question, the last question for this class. If you can solve this question with this hint even, that is a good thing that you have understood the concept of center of mass. So I'll give you 1 more minute after this hint to solve the question and let me know the answer. So how are we supposed to do this? If I call this C as my origin O, previously the bodies are at this position m1 and m2, their distances are x1 and x2. Now if I in this type of question, it is always good to take the origin at the center of mass. So one is on the right side, one is on the left side. You can easily say that m1 into x1 will be equal to m2 into x2. Do we understand how I've written this? It's very easy to do it in this way, to take the coordinate system at your actual center of mass, because center of mass remains constant or same. So m1 into x1, if I call x1 as negative, so minus m1 into x1 plus m2 into x2 divided by m1 plus m2 will be 0. Effectively, what it means is m1 into x1 is equal to m2 into x2. Do we understand this? Yes or no? Now, when I shift this one by, let us say, d1, let me shift this one by d2. Now, when I shift them, the center of mass should remain at the same position. When I shift them, then I have this equation m1 into x1 minus d1 would be equal to m2 into x2 minus d2. Yes or no? No, yes. Because the center of mass has to remain at its original position. Now you have two equations. And from those two equations, you already know that m1 into x1 is equal to m2 into x2. So what are you going to get? You are simply going to get m1 into d1 is equal to m2 into d2. Yes or no? So how much is the distance d2 that you have to move the other body? The distance d2 will be m1 by m2 multiplied by the distance d, and that is your answer. And remember this question because such questions are very likely to come. Everyone understands how I have done this? Yes or no? Anyone got the answer on their own? Well done. If you could get your answer on your own, that is great. I hope everyone has noted down this question and everyone has understood what we have done in today's class. Yes or no? Great. We will continue our journey in the next class. Up till now, we were dealing with point masses, system of point masses. These are known as discrete particles. They are separate particles, small particles. The next class, we will go on with some continuous bodies and solve questions on those. So I'll see you tomorrow. Take care. God bless all of you. Bye bye, everyone.
Thank you, sir.
Bye.